Over to you, sir.
Thank you, Poonam. Dinesh, are you able to hear?
Oh, okay,
Yes,
sir.
sir. Yes, sir. Yes, sir.
Okay, thank you. At the outset, I welcome our distinguished guest speaker today, Dr. Lata Gautam, Associate Professor in Forensic Science, Anglia Ruskin University, Cambridge, UK. And she will be speaking on forensic drug analysis. So on behalf of Vaishnav Institute of Forensic Science, Vaishnav Institute of Science, and Vaishnav Vidyapeeth Vishwavidyalaya, I welcome you to this webinar. So we are very thankful to you for agreeing to give this webinar. I don't know what's the time like in your, you are in UK? Okay, so this webinar on forensic drug analysis, everyone realizes there are many students here. I see that about 170 participants are hearing right now. And in forensic science, probably the drug analysis occupies a very important area in the present times because although forensic science is more into criminology, this drug abuse has become a passion rather than a crime because more the affluence is growing in the society. We are now seeing, at least in the Indian scenario, the drug abuse is also correspondingly becoming higher. And probably that requires an analysis also to establish, since many people are using the drugs which are mostly banned by many governments and at many places. So I think the forensic science laboratories have become more active now because of these cases coming to them for analysis. So I'm sure Dr. Lata Gautam's lecture will be very useful to all the students to know more about what's happening in this area in forensic science. For the information of our guest speaker, we are a multidisciplinary university. Forensic Science Institute is part of this university. Otherwise, we have 4 major verticals in this university: science, management, engineering, and social sciences. The 4 major verticals and about more than 20 departments working in these areas. And whenever you visit Indore, you are most welcome to come to our campus. Although right now we are online for everything, not only for webinar, but also for our regular class lectures and other things we are on online. But we hope to be soon go on offline, expecting the third wave to come down, and then we may go offline. So you are most welcome to our campus whenever you can make it to India and to Indore. So with these words, I welcome you once again. Over to Poonam.
Okay, thank you, sir. Now
Poonam, the camera
yes.
is not working, or it's not
Okay.
proper.
Okay, okay, sir. Yes. Yes. Now I will invite Dr. M.P. Gautam, Professor, Institute of Forensic Science and convener of this webinar, to introduce today's speaker. Over to you, sir.
Good. Thank you, Poonam. It is a matter of pleasure for me to introduce our today's speaker, Dr. Lata Gautam, who is Associate Professor of Forensic Science at Anglia Ruskin University, Cambridge, UK. She is also a Senior Fellow of Higher Education Academy, United Kingdom, and a member of Royal Society of Textile. Dr. Lata Gautam obtained her PhD, MSc degree in 1998 in plant science. Dr. Guru Shastra. She obtained MSc in plant science with specialization in plant physiology. And now she's in forensic science.
Oh, yeah.
From Tribhuvan University, Kathmandu, Nepal, and obtained PhD degree from Angelia Ruskin University, Cambridge, UK in 2007. Dr. Lata Gautam.
So you are muted.
Sir, you have to unmute. So, Dr. Lata Gautam, it's nice to know that you are from plant science and also in plant physiology, because that's the area where I work.
Oh, well, I figured that out. Thank you.
Gautam sir, please unmute.
Okay.
Yes. Yes.
Now I will again read it. It is a matter of pleasure for me to introduce our today's speaker, Dr. Lata Gautam, who is Associate Professor of Forensic Science at Angelia Ruskin University, Cambridge, UK. She is also a Senior Fellow of Higher Education Academy, United Kingdom, and a member of Royal Society of Chemistry. Dr. Lata Gautam obtained her MSc degree in 1998 in plant science with specialization in plant physiology from Tribhuvan University, Kathmandu, Nepal, and obtained PhD degree from Angelia Ruskin University, Cambridge, UK in 2007. Dr. Lata started her career as a forensic scientist at National Forensic Science Laboratory, Nepal, where she examined various kinds of forensic attributes and helped in the criminal investigation. In the year of 2006, she joined Ruskin University, and there he started research work. And Dr. Lata's research interests lie in chromatographic and mass spectrophotomic analysis of drugs of abuse and pharmaceutical compounds from human hair, nails, and saliva, including animal hair, water and wastewater samples, etc. In addition to these, she is also researching on analysis of seized street drugs, spiked beverages, food supplements, green tea, and herbal medicines. Now, it is very interesting. Specifically, she has focused her research activities on drug-facilitated sexual assault investigation. It is very interesting and very important, and increased awareness of such cases among students, forensic scientists, police officials, legal professionals, and education authorities, and sharing knowledge to increase public awareness. In different countries, including Belgium, Botswana, Canada, India, Nepal, Portugal, South Africa, United Kingdom, and United States of America, by a different forum such as webinar, conferences, and workshops and exhibitions. She has more than 20 years of experience in analytical forensic chemistry and guided 8 MPhil and 8 PhD students. More than 40 research papers published in international journals are in her credit. She is a member of advisory board of the Journal of Forensic Chemistry and Toxicology. Madam has many prestigious positions like member of Royal Society of Chemistry, member of International Association of Forensic Toxicologists, UK representative of UNESCO Associated Schools Cooperation Council of Nepal, and some other reputed committees and editorial boards related to forensic science. She has also received, she is a recipient of many grants and awards also. In addition to above, it is very interesting that she is also associated with the media also. Just like BBC Cambridge Radio, very interesting, and BBC Nepali News, and similarly ABC, the Drum Television. We are pleased to have such a personality with us, a forensic scientist and social worker as well. Thank you very much.
Thank you, sir. Now I would request Dr. Lata Gautam, madam, for her deliberation. Over to you, ma'am.
Yeah, thank you. Thank you very much. I'll start sharing slide.
Okay.
Right. Thank you very much for such a lovely introduction. Hopefully my voice is clear enough, and I hope to live to that expectation. One introduction was wonderful. Yes, I'm from Nepal. I studied up to masters in Nepal and then came to UK. So I had 5 years work experience in Nepal before coming to UK. When I did PhD, then that's when I started my research journey. From January 2022, I'm working as our faculty's race equality lead, as well as then teaching staff. So in my presentation today, I will talk about street drug analysis, the drugs that are found or bought and sold on the street, the drugs that our kids and brothers and sisters are addicted to, the drugs that are in current circulation in market. These are illegal drugs rather than the drugs that we buy from pharmacy. Then I will talk about drugs profiling concept. On each of these topics, we could have few hours actually in terms of students learning in detail. If anybody is thinking to learn about these topics for their project, I'm happy for you to contact me. That will then take us to toxicology or wildlife forensics, environmental toxicology, forensic toxicology concept. So the drugs that we detect from different sample types, spiked drinks, it's a very recent, quite common problem. It's really recent for UK. Drinking water, we wouldn't have thought drugs could be in drinking water. It should not be. Whether we have detected any drugs in drinking water, that's something I will share with you. Wastewater, why is it important to study wastewater as forensic scientist? I will talk about that as well. Human hair, and that's what my PhD was based on. So drugs detection from human hair. Any of the things that we learn that can be applied in other discipline. And for students specifically, I would like you to think that from that angle. In my introduction, it was mentioned that I did my master's in botany or plant science. From plant science, how am I working as a chemist now? So I'm analytical chemist, drugs chemist, and toxicologist. So I apply the chemistry knowledge that I have into different discipline. One example of that is animal hair and feather analysis. It's exactly the same principles I used as human hair analysis. And I will finish off with herbal medicine analysis that links with food forensics, and that's a growing discipline. Herbal products, herbal medicines, analyzing tea, olive oil products, and so on. I would like to start from this graph. It's quite old because it finishes in 2012, but it gives us the message that we wanted in drugs chemistry field. So if we look at this graph, in x-axis, we have time in a year, starting from 1912 until to 2012, 100 years history of what is happening in drug. In y-axis, we have number of substances under United Nations control. The blue line represents natural drug. So then in terms of natural drug, we might be finding more about some products, some plant-based drugs that they have existed, whether their potential has been realized or not, and whether they have been their abuse has increased or not. So if we look at what drugs are in United Nations control, blue line represents for the natural drugs, and the reddish line represents for synthetic drugs, drugs that are man-made, made by us. You could see steady increase in synthetic drugs from 1948 onwards, and that graph probably has gone up because there are more and more synthetic drugs emerging in market. And we have, rather than even just calling drugs, we have in UK we have Misuse of Drugs Act that controls for drugs of abuse, and we have a second legislative document which is called NPS Act, New Psychoactive Substances. Okay, so therefore it's important to think how, when this change has happened. The second, fairly old again, the graph, the data comes from Forensic Science Services when we had in UK. We don't have Forensic Science Services as the organization in UK anymore. But this is again quite interesting data for drug chemists. So the blue bars that we see represents MDMA. MDMA is one of the amphetamine type of drugs. It's methylene dioxymethamphetamine. Okay, that's the full form of MDMA. So blue bars are representing MDMA, the seizures, number of records from Forensic Science Lab in UK back then when we had those labs. And the red bars that we are seeing represents, at that time, new drug, piperazines. Amphetamines, we know about amphetamines for a long time now, they are controlled, but piperazines started emerging in 2006, 2005, and their prevalence has increased, their records, the seizures have increased, that as you can see in the graph. Why would that happen? So what had happened was MDMA, there are different methods of synthesis. The precursor, the main precursor used for MDMA synthesis was seized in huge scale. So if large amount of precursor material is seized, it is going to affect the drug distribution chain. So it did affect. So then MDMA, when the precursor was less available, or where there was strict monitoring and control, drug chemists, we call them clandestine chemists, those who are making drugs at home or non-lab setting, they then started making completely new type of drugs, very similar to amphetamine type in terms of how this group of drugs acted on human being, but quite different. So it's a different class of drugs. So piperazines started emerging in the market. Piperazines were then controlled back in 2009 in UK. Cathinones as a new group, quite similar to amphetamines, so stimulants drug, they started emerging in market. Cathinones were controlled in 2009-10. Then we have now spices and various different types of drugs in market. So today I will talk to you about the different type of drug-related research that I have been involved in. In this table, I have the types of compound I focused on, or my students have focused on, because research is not possible just by one person. It's a collaborative work. So lots of people are involved in what I'm presenting today. In terms of detecting organic compounds, the method of sample preparation, we have used liquid extraction or solid phase and solid phase extraction. In terms of analytical techniques, we have used gas chromatography with mass spectrometry detector and liquid chromatography with mass spectrometry as a detector. In terms of inorganic compounds, especially when it comes to herbal medicine analysis, we are looking at adulteration. So we targeted certain metals and heavy metals that should not be present there. So we used acid digestion as a method of sample preparation and ICP, inductively coupled plasma spectroscopy, as the method of analysis. I will start from street drug analysis, the drugs that are seized on the streets by police forces. We were fortunate to have access to drugs that were seized by Cambridgeshire Constabulary, Cambridge Police. We have good collaboration, working relationship with them. In this paper, we have focused on piperazine type of drugs because they emerged in market, as we saw the graph earlier, from 2005-6, and they peaked in 2009-10. So in this paper that we have developed a method, GCMS-based method, that allows for separation of 19 compounds, some drugs of abuse, some adulterants, and other compounds that were reported as being mixed with piperazines. It's okay to have a method. There are lots of methods type of paper, but what also makes this paper different is we were able to separate isomers of some piperazine, specific piperazine types. FPP stands for fluorophenylpiperazine. To make piperazine concept clear, in case we don't have problem about piperazines in India, so most common drugs were BZP, which is benzyl piperazine, TFMPP, trifluoromethylphenylpiperazine, and FPP, fluorophenylpiperazine. So basically, all these drugs have names as piperazines, but they have different functional groups by which individually they are different drugs. So our method allows for separation and detection of isomers, positional isomers, 2-FPP, 3 and 4-FPP, as well as isomers of TFMPP. To share chromatogram with you, so this is the chromatogram of 19 compounds with their internal standards, so additional internal standards. The method was based on gas chromatography, mass spectrometry. So we could see FPP, 2 FPP here, 4 FPP, so that's isomer of FPP. In the same way, you can see 3 FPP, so 3 isomers of fluorophenylpiperazines were separated by using this method. You could also see 2 TFMPP, trifluoromethylphenylpiperazine, 3 TFMPP and 4 TFMPP. So isomers were separated because it's difficult to separate isomers using gas chromatographic technique. So what were the highlights? This slide shows you examples of samples that we received. So samples, these drugs were seized by police. A1, both of these compounds, the drugs are in tablet form. As a drug chemist, you would look at logos, imperfection in logos, you will take note of ballistic characteristics and so on. So the mass is recorded, the picture is taken with a dimension. Always remember that from strain point of view. But our interest was finding out what is present in these tablets, which piperazine is present. So BZP, benzyl phenylpiperazine, was quite prevalent at that time, and probably BZP was expected, but TFMPP was emerging in market and media was covering that compound too. So you could see it was a combination of BZP and TFMPP, one of the forms of TFMPP. But we also saw dibenzylpiperazine. So dibenzylpiperazine is formed during the synthesis of benzylpiperazine, actually. So now we need to think, if somebody was buying this drug thinking it's BZP, that person, without realizing, ends up taking TFMPP and DBZP. Okay, so BZP itself, it has pharmacological properties. Now think about having that mixture. What about which drug is more potent? We don't know at that stage. So therefore the user actually, even though it might be smaller dose, the effect for user could be it could be big consequences. So it's important to think about the adulteration, what else is present. And the drug on itself, yes, they are problematic, but rather than that, something being added on the street in distribution chain or at manufacturing point, that's big problem. If these drugs are laced with or mixed with something more toxic, these days fentanyl, what would happen? The people could die. Right? So if we look at the second example, we could see BZP, TFMPP, same compound, and DBZP, but caffeine is added. Caffeine is stimulant as well. So the effect from the drug itself as well as adulterant could potentiate the reaction on people. So we really need to, therefore, it's really important to know what drugs are in circulation, what else is present in that drugs. It's really important to make informed decisions, even by those who are using drugs, because what you are thinking you are buying might not be what you end up buying. Okay. So the second project that we worked on was related to ecstasy. Ecstasy normally is meant to be MDMA, so methylene dioxymethamphetamine. So what happened in literature is people started using MDMA and ecstasy interchangeably. So is ecstasy MDMA, or do we mean ecstasy includes any other form, amphetamine type of drugs, but with methylene dioxyfunctional group? So that was not clear. MDMA, people started thinking as pure form, but it's not. MDMA is one compound within that family. Then you have MDA, MDEA, so other methylene dioxy group present in the amphetamine type of drug. So this research included survey looking at what is happening in media, but also lab work. So I'll share some results from lab work. For this research, again, we worked with Cambridgeshire Constabulary to access the drugs. So you could see the drugs as powder form, crystal form, and as well as tablet form. So should we expect all of these to have MDMA, or are other compounds present? You could also see different color there. We could see white powder. You could also think about the wrapping material from student point of view for projects. You could think about physical fit of these wrapping materials as a project to see whether you could link with the drug distribution or where the drug originates from. So these are just some examples of the samples that we had analyzed. So the first sample looked white powder, mephedrone was detected. Okay, if we are expecting MDMA, which is methylene dioxymethamphetamine, so amphetamine type of drug, mephedrone, very potent. It was quite toxic at that time. It was reported in media quite a lot. So mephedrone is methyl methcathinone. Okay, so it's a new class of drug, cathinone type of drug, methcathinone, so with methyl functional group. That's the mephedrone. But what we detected, mephedrone that was also mixed with methyl eth-cathinone. So ethyl group was added. So it's a new functional group, right? It's a different functional group. So two combinations of cathinone drugs were present in that one sample. Would that buyer would have known? No. Would the seller would have known which one is more toxic? What about if both of these were potentiating the reaction? Okay, so other samples we have MDMA in all of them, meaning we detected methylenedioxymethamphetamine. But you could see now what secondary compound was present. With MDMA in one sample, benzocaine was present, which is an anesthetic compound. In MDMA, we also detected TFMPP and BZP. These are piperazine type of drugs. In other MDMA, we detected methylone, which was again, its methylone is MDMA equivalent of cathinone. So similar structure, cathinone has a functional group, ketone. So if we can imagine as MDMA with ketone actually becomes methylone. So it's a very simple functional group changes. So those two examples are from PhDs that I supervised. But currently, we are supervising a PhD student who is looking at heroin profiling. And those who are working on drugs chemistry field might think, oh, there are plenty of papers in heroin profiling. Yes, heroin profiling has been done. So what we are trying to do is we are testing certain hypotheses by which we are seeing whether the assumptions made for data analysis still are valid or not. So we are using chemometrics to see that. Just to remind ourselves from lovely poppy plant, in those buds that are there, if caught in-season mark is made, the resin that comes out is collected, dried, that's our opium. And from opium, morphine is extracted, then hydrolyzed or reacted with acids to form heroin. So that heroin sample seized by Cambridge police is what we are analyzing again. When we analyze heroin, initially starts from plant source. Obviously, in that plant, lots of different active components are present. Morphine itself, monoester morphine, codeine, acetylcodeine, papaverine, and so on. All these different active components are present. In order to know whether heroin comes from one country or the other, if we look at a relative proportion of all of these different compounds, we will be able to establish whether the heroin seized in Cambridge matches with the heroin seized elsewhere in the country. Now let's look at application of that chemistry knowledge into toxicology discipline. If somebody is exposed to drugs in tablet, powder, or whichever form, or alcohol in high amount, or spiked drinks, then the type of samples in toxicology we analyze are either blood, the most commonly analyzed sample is blood, urine, preferred sample, blood is used for quantification, urine generally for screening. Hair sample can be analyzed. I'm not sure in India whether we have started hair sample analysis or not. In Nepal, we have not. So we provided training and labs are now ready to start, but they haven't received samples yet. Depending on the type of case, for example, on spike drinking or drug facilitated sexual assault, you could analyze drink samples as well. About these different samples, they have their strengths and weaknesses. For example, if we are looking for drugs in blood sample, and especially if we are looking for drug facilitated sexual assault cases, the drugs that are used, they have shorter half-life. So the drug could be cleared from the body if sample is not collected at right time. So blood sample is used for up to 48 hours in terms of detecting or increasing the chance of detection of drugs. Urine sample would be fine for using within 5 days of the incident. Especially this is bearing in mind for DFSA cases. Hair sample is generally collected a month later, but it can be collected at any time, and it depends on how long the hair is. And also it doesn't have to be just head hair, any other body part hair can be analyzed. Drinking glass bottles, vomit, if they're available, they can be collected. So this slide, in this example, I have specifically used guideline from UNODC for DFSA cases. For general toxicology cases, again, blood and urine sample are most analyzed sample. Because I'm going to talk about hair and drink analysis, so I wanted to justify why I'm focusing on those. Because of shorter window that we can see from blood to hours to few days, then from urine sample, you can go from days to weeks. For DFSA, it's recommended for 5 days, but in terms of detecting drugs, even from blood, drugs have been detected for 28 days. So the window varies depending on the drug. From hair sample, we can detect drugs from month to years based on the length of the hair sample. So that takes me to drug-facilitated sexual assault specific research. We have published this paper, and our intention was to provide information for doctors and forensic scientists in one place about all potential drugs that are likely to be used in drug-facilitated sexual assault. So drug-facilitated sexual assault is non-consensual sexual act when the victims are incapacitated by drugs or alcohol, and therefore they are unable to resist or unable to provide consent. So that's drug facilitated sexual assault. So basically, sexual assault that takes place when the victim is under the influence of drugs and alcohol. There are two types of such cases. One is opportunistic DFSA. So what I meant by that is, if I was drug user already, or those people who are using, not necessarily abusing as well, but it could be pharmaceutical compounds they are prescribed to use. Somebody takes advantage of the situation when the person has used drug themselves, as opposed to predatory is where somebody goes out with the intention to add drugs or high strength alcohol to somebody's food and drink. That's predatory cases. We have been working in Nepal on drug facilitated sexual assault project, and we noticed third type. And that third type is where perpetrator actually consumes the drugs and alcohol, and under the influence of drugs and alcohol, rather than spiking victim, they commit such heinous crime. So that we wanted to look at what drugs are then involved. There are more than 80 different drugs mentioned in United Nations report. So some to classify, so we see the names of drug or class of drug, mostly benzodiazepines, GHB, ketamine, they feature a lot in DFSA context. What we wanted to know is what are the forms of these drugs? So generally drugs are powder, tablet, unless natural, it could be dry plant parts and so on for cannabis especially. Otherwise they are like powder, tablets, a liquid, and so on. In terms of solubility, these drugs are soluble, quite easily soluble in water, aqueous media, as well as ethanol. But benzodiazepines, so-called candidate drugs for spiking, are not easily soluble in water. So these drugs are not easy to spike the non-alcoholic drink. Then what we wanted to look at is what is happening in different countries. So we have data here from USA, UK, Northern Ireland, Canada, and Norway. Since we published this paper, there are a few countries where the data is available from. So we wanted to see what drugs are appearing in different countries in DFSA context. So at the bottom, we see negative, and it looks like 30, 40 to, depending on country, quite significant proportion of cases are negative. So these results are from urine and blood sample of the victims where the sample was submitted to forensic labs of their country. And while analyzing these samples from DFSA point of view, where drugs and alcohol is present, you could see lots of cases were negative. Is it because the drug was not used, or is it because the sample, the drugs have shorter half-life, hence drug was already eliminated? So we need to think about those when we report negative results. Negative results does not automatically mean drug was not there, okay? Then you can see quite significant proportion of cases, about 40% cases had alcohol positive, but alcohol with other drugs or alcohol without other drugs. So you need to be careful on that too. Then out of the drugs of abuse, we have cannabinoids as the other group. One can think on how is it possible to spike cannabinoids? Maybe as brownies, somebody makes brownies and adds cannabis in that, or maybe adding some food product. But also we need to think some people would be using drugs themselves, so it's not necessarily just spiking. So we need to be able to differentiate what is spiked versus what actually was used by the person. Then out of remaining drugs, you could see benzodiazepine featuring next. So third most popular compound out of the compounds that are reported. Then cocaine, amphetamines, and all other types of drugs. What we wanted to then do is look at which drugs are used in predatory cases as opposed to opportunistic DFSA. We listed these drugs. We then looked at different literature from different countries, and cross means that drug was not detected. Tick means that drug was detected in the study from this specific country. So if I take you to next slide, where we found benzodiazepines, where you can see all ticks for predatory cases. So somebody intentionally spiking somebody's food or drink. So that happened for benzodiazepine type of drugs. But also benzodiazepines are pharmaceutical compounds. Therefore, people might have been prescribed, might have used themselves. So you could see it was also detected in opportunistic DFSA. The other group of drug that was interesting for us was cocaine. Cocaine was not detected in predatory DFSA. Obviously, some studies didn't include certain drugs, therefore not included in Norway. But cocaine was detected in opportunistic, somebody taking advantage of the situation. So from this slide, looks like cocaine is a drug that was used by the users rather than spiked by somebody else. The other group that we found interesting was opioids like heroin, morphine, kind of compounds. They were detected in both opportunistic as well as predatory DFSA, except UK did not have opioids in predatory DFSA. This takes us to looking at how long can we detect drugs from spiked beverages. If somebody is to report to police or report that case on time, and if drinks are collected, how long can we detect it for? How should we store these samples? So what we did in this research is selected which drug to focus on. So from earlier cohort study, the graph that we have seen, negative were quite significant proportion. We had alcohol, cannabinoids, and benzodiazepine, right? So cannabinoids are likely to be drugs abused by individuals rather than spiking. Therefore, we focused on benzodiazepines as our drug of choice for this research. We selected 5 most commonly purchased drinks by certain age group, more likely candidates of DFSA victims. That doesn't mean older generation or other people are not victims. The age range is quite widely. So we selected 5 drinks. We spiked these drugs into those drinks and stored the drinks in refrigerator, room temperature, light and dark for 25 days to see can we detect these drugs. So these are some examples of results. So we have this first graph is related to flunitrazepam. We have 5 different colors in each block that represents 5 different drinks that we have used for this research. From time 0 in x-axis, we have different timeline up to 25 days. So seeing the variation in the individual variation shows the fluctuation in the results, but overall variation shows has it decreased? Is there a trend or is it stable? So one can say, okay, there is some decrease. We need to analyze this data further. For diazepam, we could see again similar trend. Is it significant difference between the samples analyzed at different time? But when it comes to temazepam, which is one of the other benzodiazepine, temazepam is widely reported in Nepal and India for students' information. So it's quite heavily abused drug. So in temazepam's case, you could see there is significant difference when it comes to especially J2O. Really lot of difference, 97% loss of temazepam in J2O. But the good thing in this slide is though, for 25 days, we still are able to detect all of these drugs. If the samples are collected on time, stored appropriately, we still are able to detect these drugs up to 25 days. But we need to remember how to store these drugs properly so that we have chance of detection increased. We also need to remember for data interpretation, as concentration wouldn't really matter if the drug is not meant to be present in that drink. Why should that drug be present? So therefore, except GHB, other drugs should not be present in drinks. GHB is sadly present in certain drinks, grape-based beverages. So therefore, we need to be careful on that too. So the method that we used was liquid-liquid extraction, and the instrument we used for this research was gas chromatography mass spectrometry. I have been involved on awareness raising. I am now 46 years old, soon to be turning to 47. I realized the importance of, sharing what I know and making people more aware of certain problems, specifically on drugs related things, so that people can make informed decisions. People can report on time. So for students, I would really appreciate you guys to listen to the podcast that was done by Dr. Susie Gaze. She is author of Say Why to Drugs. Her book is really simple, gives simple explanation about different types of drugs, and her book also has the same intention of making people more aware so that people can make informed choices. The second link is about conversation article. In October 2021, we had several news reports in the UK about increase in drink spiking, and the trend had changed. So normally drink spiking is something is added to the drink. It could be drugs, pharmaceutical compounds. It could be alcohol for those who are not drinking alcohol. It could be adding high strength alcohol when somebody is buying low strength alcohol. But what happened in October 2021 was needling, somebody injecting somebody. That was featured in our news, BBC News. it was just timely at that time. We had just finished 2 surveys, and probably it's one of those rare things. It's just coincidental. Our surveys had finished, those incidences came in light, so we were able to publish paper in Conversation to make people aware of what is happening. From the same, if one thing links to other, okay, so that link to Australian Broadcasting TV program, that link is still active. Therefore, please do watch it. It's for awareness raising on how to protect yourself from falling the victim of these crimes as well. As part of research excellence framework, that's something all UK universities undergo every 5 years. Drug facilitated sexual assault is one of our impact case study for Anglia Ruskin University. What this meant is I have run lots of workshops in schools and colleges to make students aware, because in Nepal, we didn't really see that as a different pattern, different type of crime from sexual assault. Because the behavior, the nature of drug, the effect of that drug is very different from other type of or sexual assault or rape crime. Therefore, I wanted people to be aware that victim might not report on time because of this, or victim might give you fragmented information because the effect of the drug, meaning they lost their memory. So we have been running lots of programs like that. And I really would like to actually offer similar program in India as well. I have students, research students who are based in Botswana. They are working on drug facilitated sexual assault and wastewater analysis. So students are from Botswana. I'm co-supervisor. And we have conducted survey-based research based in Nepal and also online surveys. So we can really see which country that represents. So chemistry knowledge can be applied to other fields. Now I'm going to take you through environmental forensics and drinking water, where we wouldn't expect drugs to be present, okay? So we detected several drugs in drinking water. Drinking water analysis is not a new field. Lots of researchers have been involved. For this specific research, we have used LCMS as a method of analysis, solid phase extraction for sample preparation. We targeted several drugs, and our method allows for detection of 20 drugs and pharmaceuticals from drinking water. From the sample that we analyzed, we did detect citalopam, cocaine, fluoxetine, ketamine, mephedrone, and methamphetamine and methadone, which is cathinone type of drug. So we detected these drugs. We quantified how much is present. One can say, well, it's a very small amount. Yes, it is small amount, but we are drinking, what volume of drinking water we are meant to drink every day? We are exposed to that quite a lot. We need to drink more water. Therefore, even if it is smaller amount, lipophilic drugs might gather in our fat tissue. Therefore, we might have toxic effect without realizing it. So therefore, probably the removal or testing process has to be thorough in drinking water supply mechanism. For those who are interested in terms of method, you can access the full text paper, but also have copied the mobile phase composition and so on. So this is chromatogram from LCMS, where we have reported detection of 23 compounds, but 23 meaning we had 3 internal standards. We used deuterated internal standards, and we targeted 20 drugs of abuse of anti-pharmaceutical compounds. This then takes us to wastewater. So why interested in suddenly in wastewater? When I realized how important wastewater analysis is, as opposed to you have survey, you have street drug analysis that complements wastewater data. To collect wastewater, it's not intrusive. So if you can access the wastewater sample, it gives you the pattern of community drug use. So what is happening in that area where the wastewater is collected, or that serves for. So if we think about cocaine as a parent drug, if I have taken cocaine as an example, or I am exposed to cocaine, it metabolizes in my body and forms benzoyl-lignin. So through urine and feces, cocaine and benzoyl-lignin ends up in sewage treatment plant. Drugs half-life is different. It is different for different drugs. So parent drug might not be detected in some cases. You always target for metabolites and parent, if parent drug could be detected. So from sewage treatment plant, so all sewage treatment plant, they treat that sewage, and once treated, that's then used as surface water in rivers. Now we can imagine, we might think as forensic scientists, so what, I'm not bothered, but we do. It disturbs our ecosystem. So what about aquatic species? If there are drugs present, there are toxic compounds present in water, then aquatic species are exposed to. So suddenly the whole ecosystem could collapse from this. Therefore, it is very important to think about you're using your knowledge outside of that box and to other disciplines as well. Okay, so we collected untreated wastewater sample. We extracted using liquid and solid phase extraction, and you detected drugs using gas chromatography, mass spectrometry analysis. So again, why wastewater analysis is important? Because sample collection is easy. You're not invading anybody's privacy. It's non-intrusive. It's real-time data. Because if you collect survey, so I did survey in 2018 on DFSA in Nepal. I'm still working on reviewers' feedback on those paper. So you could actually, it's real, so you can get the real-time analysis of what is being used by that in that community at that time. So it's quite easy way of getting the information, but you cannot pinpoint on households because the sewage serves for a certain population. This is chromatogram where we have reported the types of drugs, the number of drugs that we have detected. So we have, I think it's 31 or 32 different compounds that are detected. That includes internal standards that were used. So solid phase extraction as a method of sample preparation, GCMS as a method of analysis. So what we found, so we developed the method that is suitable for analyzing the several drugs of abuse and pharmaceutical compounds, but we reported the detection of butylone. Okay, butylone is butyl version of methylone. Methylone is equivalent of MDMA. So you could see how the drug trend is changing. So newer form of, once methylone was, people knew about methylone, butylone came in market. So you could find the information from sewage sample on what drugs we might not have captured otherwise. So butylone, mephedrone, they are both cathinones. You can see piperazine, fluorophenoyl, FPP, and methoxyphenyl, neopiperazine. At that time, these are no more new drugs, and benzyl piperazine. So we basically reported cathinones and piperazines in wastewater, and these were the class of drugs that were quite prevalent at that time when we analyzed the sample, meaning the regular studies have to be conducted if we want to know what is happening in our community. So our recommendations were, then we need to have constant monitoring of these drugs in wastewater so that our data, meaning in government level, national level, complements what is happening on street level. So these treatment plans or sewage treatment plans, then they need to put plans in place for drugs removal, especially if they are discharging water into river or other sources. So this takes us to hair analysis example. Our hair grows approximately 1 centimeter a month. Hair growth rate is variable, actually. It's quite wide range. That's one of the negative thing of hair analysis. So let's say we have the person is exposed to drugs at this time. So that blue now indicates drug. This is length of hair. So the person is exposed to drug at this point. Now you will see hair growth rate, hair growing in next slide. Next month, that drug moves into the other 1 centimeter. Then following month, that drug actually moves to other centimeter. So if we are looking for somebody being exposed 3-4 months ago or a year ago, hair is the only sample that provides you that information. You can't get that information from blood and urine. Therefore, for certain case types, hair sample analysis is really, really important. If we are looking for timeline or history of drug use or abuse, then hair analysis is very important. In terms of analyzing hair, it's very simple and straightforward. It is time consuming and the instruments needed are, it has to be sensitive techniques, but GCMS and LCMS that we have used for other things. So for sample collection, you collect from posterior back of your head, posterior vortex prism. Normally the thickness of pencil width is what is collected. By saying that, people have reported detection of drug from one strand of hair, but in terms of general case, for forensic case, that's what we would collect. You just wash it to remove external contamination. You cut it using scissor or ball mill to make it powder. You can extract then using solid phase extraction or liquid extraction, evaporate, and then derivatize based on what drug we are targeting, reconstitute and analyze by GCMS or LCMS. It has lots of advantages because it gives long-term drug use history of the person. It's easy to collect, less chance of contamination, stability of drugs in hair. Obviously, due to perming, coloring, and different cosmetic treatment, the drug might leach out. However, it's more stable than other sample type. But obviously, it is not without any problems. It has issues. For example, hair growth rate is different for different individual. Based on ethnicity, it could be different. And also how results are interpreted is quite different. Therefore, this takes us to the next paper we have published. There is no standardization across different labs. There is organization called Society of Hair Testing. So it provides guideline. But within that guideline, people, specific labs follow their protocol. So you need to just be careful with interpretation. And what we then did is we have published this paper. We looked at various issues that, and it's again from PhD student I'm currently supervising. He's focusing now on microsome study, looking at metabolites of designer benzodiazepine. But early on, we published this paper where we have divided different factors into 3 stages. Stage 1 has lots of things that are not within our control. So as chemist or forensic toxicologist, how much drug is used, how was the drug, what mode of that drug intake was, how often the drug was used. That's not within our control. We might get some information, but we might not know anything about it as well. In stage 2, we also grouped variables that are not within our control. But as analysts, as forensic scientists, you do need to know about these different factors when you are writing your report and interpreting things. But stage 3 has factors that are within our control. For example, where did you collect sample from? How did you store? So did you store it in light or dark? Did you collect it from posterior vortex? Was it head hair or hair from different parts? How did you decontaminate or wash your hair sample? When you were washing, did you leave it in dichloromethane as an example for too long, by which the drug might have leaked out? So you need to think about those. Did you analyze the last wash so that you could have established there is nothing that is leaked out? The analytical technique, have you used method that is validated? Or did you need to do the validation? And how did you interpret that data? For example, especially for GSB, that's naturally present in our body. So in everybody's hair, we will detect some level of GSB. And GSB is one of the candidate drug for drug-facilitated sexual assault or drink spiking. So we need to be careful about these things. So these variables can affect the outcome of hair analysis results. Therefore, scientists have to be careful. What is needed is really standardization of these stage 3 or phase 3 variables would really be very helpful, but labs are using the methods that they have developed. I will now link our research with wildlife forensics. And now people might think, so what, why? Again, let's think about our ecosystem. In 1990s, we lost 95% of world's gyps vulture species from Indian subcontinent. And we still have that. That's a kind of problem. It's still in India or in Nepal as well. So why we lost and what happened? Initially, people didn't know, but later on, it was linked with the exposure to diclofenac. So it's one of the pharmaceutical compound, right? So therefore, I'm linking with drugs now. So pharmaceutical, scientists knew about then this diclofenac might have contributed to that. Once that was known, then obviously countries started banning diclofenac. Sometimes this banning doesn't actually work. When diclofenac was banned in India, then people started using meloxicam, and meloxicam is equally toxic, but people didn't realize at that point. So there are several papers on just looking at what pharmacies are selling, and there are organizations, for example, BirdLife International. They are working with India partner and with different researchers. What we did in this is in this field is we have also published few papers. We looked at SIPS wool. I'm not part of the research team for the 2 papers that are mentioned in this. These are AIE research, but the first and the last one is where I'm involved. So I supervised or co-supervised a PhD student who looked at drugs detection or pharmaceutical compounds detection from vulture feather and other hair species, other animal hair. The final point for today is detection of drugs from herbal medicine. And one might think, why? Why do we need to think about herbal medicines? Again, the drugs, pharmaceutical compounds, it's not only drugs of abuse, it's just things that are not meant to be there. If they are there, it's our responsibility as forensic scientists to say what is present in these samples. So this study was, again, my PhD student who worked he was from Nigeria. So we focused on Nigerian herbal medicines for this research. We conducted survey to understand what people were using, why people were using those drugs, and what was the situation, side effects, and so on. Him having the medical background, he was a medical doctor. He also had, we worked with certain hospitals in Nigeria in collaboration. So we had access to patients' records to see how toxic, if anybody had died from herbal medicine, or in death record, if herbal medicine was the contributing factor. We examined hospital records. We also collected 10 samples from Nigeria and analyzed for organic compounds and for metals. So we selected certain metals, right? Arsenic, mercury, they are not meant to be, and we are not meant to be exposed to these metals in higher amount. There are WHO levels reported, right? So it should not be present higher than that level. So I will share those results on what we found. We targeted certain compounds, organic compounds like ibuprofen, diclofenac, paracetamol, tramadol, certain drugs that were reported in the survey as drugs that were present or quite commonly used in the population at that time. So what we found in these results, we did not find any organic compounds that we selected. That doesn't mean there was no adulteration, but compounds we selected were not present. But in terms of metals, it's really scary. That red bar, red blocks that you can see. Red is where we have above permissible, WHO permissible limit for these elements. So we had cadmium in quite high excess for all the samples, those 10 samples that we analyzed. We had chromium present in high amount, copper present in high amount, nickel was present in high amount. And mercury, obviously the technique that we used, we didn't detect mercury. So we outsourced the samples and have results from mercury. But for today's purpose, I didn't include that. So what this means now for students is to think, what would happen if somebody is exposed to higher level of cadmium? Are there any toxicity? So these could be the other smaller projects that students can work on. And how are we exposed? So if it is meant to be medicine, how do we have cadmium, copper, or other metals in higher level there? Has these metals, have they come from where the plant is grown? If so, why? Was there a dumping site nearby or environmental pollution? Or how are we exposed? Should we be exposed to these compounds if they are above WHO recommendation limit? We should not be, right? So to summarize, I have given you examples of street drug analysis and drugs profiling research that we have been involved. I didn't talk about, there is one project going on where we are looking at CBD conversion. So we are working on cannabinoids as well. We are working with designer benzodiazepines too. So these are current projects. I have given you examples of drugs detection from different sample types, ranging from water, wastewater, herbal medicines, and so on. Hopefully, this has also given you idea in terms of from botany, I'm coming back to botany. Now I'm looking at food forensics, looking at teas, green teas, olive oil, other food products or herbal medicines. And these are references. I have provided a slide as well. I'm happy for slides to be shared so that you can access full paper. I would like to thank you all for attending today, and especially organizer Sri Vaishnav Vidyapith Viswavidyalaya and all staff members, Professor Gautam, Poonamji, that I had opportunity to meet and know them virtually, for providing me this wonderful opportunity. Thank you so much.
Now, Dinesh.
Yes, sir.
Now you conduct. Poonam is having some problem.
Yes. Ma'am, we have received some questions from the participants, so I will take one by one. The first, can you detect the drug with the help of eyebrows?
Yeah, that's interesting question, and thank you. Yes, you could detect hair from even pubic hair, so therefore there is no reason why you wouldn't detect. What we need to think is, how are we detecting drug from hair? So anything that we are exposed to goes through our circulation, right? So therefore, yes, from any body parts hair, not only from hair, also drugs are detected from nails.
Yeah, thank you, ma'am. Also, my personal question is, actually, I am doing the PhD in the body hairs for detection of psychoactive drugs. So I would like to ask one question: which method is best for the extraction of the drugs from hairs, body hairs, for the identification of psychoactive drugs?
Thank you. That's a very big question. So obviously, because psychoactive drug includes, that's just the class, right? Naming, it includes lots of different drugs. So therefore, we need to look at functional group, I guess. Otherwise, there are general methods that we recommend. I'm happy to share, and we use we offer a practical for our master students on detection of GHB from human hair. For that, because I want students to be quite independent, so I have compiled 3-4 different methods of sample preparation, hair washing. I'm happy to share that information. My PhD was on hair analysis. My supervisor's expertise was on hair analysis. So kind of, I'm happy to point you to write papers if that helps. And I would say, if you haven't already visited, so Society of Hair Testing is very important place for that. They have published guidelines on it. So there is no specific method that would be good. It will depend on what facility you have available. So I would never say this method is better than this. Maybe sensitivity wise might be different. I'm quite happy to actually have offline conversation on that, and really happy to help you.
Thank you, ma'am.
Yeah, thank you.
Any more questions?
Yes. The one question is the wildlife poisoning special concern to the tigers. If you had worked with this type of cases.
I have not actually worked with those cases, but if there is anything we could do, really happy to help. It's the different type of compounds are being used, and also, I'm not sure what type of angle we are taking in tiger cases, especially in India, but I'm aware of certain countries where community were affected by exposure to these animals, and they were poisoning it because they were thinking about their livelihood, and they started then planting certain plant species which was invasive species and now has affected. So that discipline itself is quite interesting to see how then human behavior changes, because they need to protect themselves, which is fair enough, but then having this plant species, how that has then affected, that's invasive species, it's growing really wild. And this is not from India, this is different country, but this has happened as well. I'm not directly involved with any work related to tiger or to, let's say, bigger animal as such, because for tiger probably people are putting something out, right? Something out for tiger to be exposed to. So therefore it won't be as, I wouldn't say it would be that difficult to detect. So it would still be the same principles as we would use in forensic toxicologies in terms of if tiger have died, then analyzing from blood or viscera tissue. So same extraction, same concept in terms of detection. But if anybody is asking and you are working in lab, I'm happy for you to contact me so that I can provide you specific, literature or any information that I can find. And also I'm happy to put you in contact with Nepal Forensic Lab. We used to get samples like that in Nepal.
Okay. How will analyze the opium derivatives analysis from hair in burn cases?
So burn cases, but hair still is there.
Yeah.
Yeah. It won't be any different than any other hair analysis method. If you are thinking just body was burned, so there was fire, therefore there are pyrolysis product and other things in hair now. In any hair that we are analyzing, it is likely to have passive exposure, things that we are exposed from outside external sources. In the same way, in burn cases, that sample is going to be exposed to other things. The washing methods that we use, simple method is wash with water, sodium. This is just simple method. Okay, there are many methods people use. So we first wash with water, distilled water, then wash it with sodium dodecyl sulfate, which acts as surfactants like shampoo, and then wash it back with water is one method. Second method people are using is wash with water, methanol, wash with water, dichloromethane, wash few times, ultrasonicate and wash it. Whichever method that is used, we need to remember the last wash must be analyzed. And if we analyze all of these washes in each step, we will see the decrease in level of the compounds being detected. So if whoever has asked this question, you are thinking about pyrolysis product and that might affect, washing step is meant to remove those. So therefore, whatever drug we are looking for in terms of detection, it should not matter what scenario that sample is collected from. It could be dirty sample. We have analyzed buffalo's hair from Nepal actually, because there was a problem once with buffalo identified. So samples could be dirty, but you may need to have more washing steps.
There are number of questions that I feel, na?
Yes,
so
sir.
it can be communicated that they should write.
Yes, sir. Yes, sir.
They will conclude. Now, what is Poonam Madam further?
Yes, sir. Yes, sir. Yes, sir. Okay.
Now, there is one comment on this lecture, Madam. As far as the DFS cases is concerned, generally, also I should say you have the experience of Nepal laboratory. Yeah. The liquor examination is traditionally conducted.
Yeah.
And the percentage of alcohol, percentage of acid contained, volatile acidity, and whatsoever it is, maybe, and some common poisons. But as you are doing the DFSA cases, means the spiked drinking.
Yeah.
This is a new approach given by you. Okay, na? Because in common practice, spiked drinking, either people don't understand, either such type of training has not been given to the forensic scientists. As I could understand. So there is a need to teach these things to the police investigation officer as well as to the forensic scientist. They should not limit their approach for the toxicology exams as well as the chemical exam of the drinks. Commonly composed is mixed in India and some, but there are some traditionally used drugs in Punjab. Punjab, they are using the chloral hydrate. It is not considered as a chloral hydrate. It is not the dry alcohol, dry liquor. It is a solid, you know, and it is a mixed. So commonly, we should not be limited our approach for as far as the toxicological and chemical analysis of the drinks. Nowadays, you need cases are increasing like this, and when you have correlate this with the DFSA, means sexual assault, it becomes more important. So especially sample collection is very important. I have seen you have mentioned you have not never talked about the bisra. You have talked about only the blood and alcohol, blood and urine. In practice, every thana police station are sending the bisra for examination. वो शराब पिए हुए था, ये था, whatsoever it may be. But blood sampling should be started in common cases. A very nice lecture, madam, and very and thoroughly you have correlated the your chemistry in herbal identification. Similar case with the me, I am a MSc in chemistry, but I am doing the work on plant poison. Correlation. And now Dr. Guprasad has come with us. He's a well-known botanist. So very nice meeting. And now I will request Poonam that.
Yes, sir. Yes, sir. My voice is clear now, sir?
Oh, yes, yes.
Okay, okay, sir. Now, I would like to invite Mr. Dinesh Kamble, Assistant Professor, Institute of Forensic Science, for words of thanks. Over to you, sir.
Thank you, ma'am. Good evening to everyone. On behalf of Sri Vaishnav Vidyapit Vishwavidyalaya, I, Dinesh Kamble, extend my heartfelt gratitude to all of you for your kind virtual presence. I appreciate Dr. Lata Gautam, Associate Professor in Forensic Science, Anglia Ruskin University, Cambridge, UK, speaker of the students webinar, taking time out her hectic schedule for delivering very useful lectures. Thank you, ma'am. Without the capable leadership and timely support from superiors, no program can succeed. On this occasion, I would like to express my gratitude to our Vice Chancellor, Dr. Upendra Dhar, for his unwavering support and motivations. I would like to thank Dr. K.N. Guruprasad Sir, Director, Sri Vaishnav Institute of Science, and Coordinator, SVIFS, for his consistent encouragements. I would like to express my gratitude to Dr. M.P. Gautam Sir, webinar convener, for overall supervision and encouragements. I would like to express my gratitude to Mrs. Poonam Yadav, the webinar coordinator, for this webinar preparations. Without the help of all SVFS faculty members and students, this would not be possible. So I would like to thank all the participants from India who have attended this webinar. At last but not the least, I am very much thankful to Dr. Anand Rajawat, Director, SVIIT, and Dr. Jigyasu Dubey, Head IT Department, along with his technical team for technical supports. Thank you all. Have a nice day.
Thank you, madam.
Thank you, ma'am. Thank you, sir.
Thank you.
sir.
Thank you,
Thank you,
ma'am.
sir.
Nice
Thank you very
lecture.
much. Thank you. Thank you very much. Thank you for the
So
opportunity.
you are very much into forensic science from plant science. I can understand that.
I have even forgotten my master's project on plant physiology. Yeah, I have started a long time ago. I started working in
Okay,
forensics. So
nice
thank
to have
you.
you here.
Thank you very much.
Okay, okay.
Thank you so much.
sir.
Thank
Thank
you.
you, ma'am.
Thank you. Thank you. Thank you very much. Bye-bye.
Thank you, Gautam sir.
हाँ सर, थैंक यू वेरी मच.
Thank you, sir.
आपको भी बहुत बहुत धन्यवाद.